Welcome back. The purpose of this video is to introduce you to linear programming and then show you how we use linear programming in business to do a break-even analysis. So with that said, bottom line here is that, as I mentioned, one of the things that we often do in business is we need to determine what the break-even point is. When do we start making a profit? When do we start seeing results? And so that is like I said, a very common thing for us to do. And with linear programming, we can solve this problem both graphically and then also in Excel or with other means. So being able to set this problem up really starts with framing it. And the idea of framing comes back to, what decisions are going to happen, knowing that oftentimes these decisions have trade-offs. Trade-off means that I'm going to do one thing instead of another. Also included in this, I have constraints. We don't have unlimited budgets. We have times when it has to be at least bigger than this or smaller than that. And ultimately, though, I have to have an overall objective. I have to know what I'm trying to accomplish with my with the decision I'm trying to make. And then if there's some way for me to take all of this information and convert it into equations, I really can take it and move it to an area to where I can solve it graphically or in Excel. Here's the approach. 5 steps. For linear programming, and again, linear programming has nothing to do with computer programming. Instead, it has everything to do with taking a problem, converting it into mathematical expressions, most of the time in the form of lines, so that we can solve the problem. It starts by gathering the relevant data. Then after that, we're going to decide, identify the decision that has to be made, list any constraints that we have, determine an overall objective or measure of performance, and then take all of our information that we have that's in verbal description, change it into some sort of quantitative expressions. Bottom line, I'm trying to answer 3 questions. What is the decision to be made, or what are the decisions to be made? What are the constraints? And then what is the overall measure of performance for all of the decisions when we put them back together? Here's an example. You're thinking about starting a sideline business, perhaps making jewelry. It's going to cost you about $1,000 for the initial equipment that you need. Stone cutting equipment, soldering equipment, those type of things. And about $4,000 to convert your garage into a shop. Right now you think that you're going to make about $25 on each piece of jewelry that you make. You need to determine, though, going into this, how many pieces of jewelry would you have to make just to break even? Okay, let me say that one more time. If this is a sideline business that you're thinking about doing, how many pieces of jewelry would you have to do to finally start making a profit? Okay, so what's your break-even point? With that, let's go back to our 5 steps. Gather the relevant data. For this example, we have it. Good. Next, identify the decision to be made. The decision I want to make here is, when will I break even? Okay. Identify the constraints. Well, since the number of the items, jewelry items that I'm making has to be greater than 0, let's put that in right now as a constraint. Next, identify the overall measure of performance, or the objective rather. And the objective is, I need to determine when will the profit finally equal my setup costs. Let's take and switch that over now into this last step. How do I take these things, put them as equations? Well, my setup costs are $1,000 plus $4,000, total of $5,000. My profit is, I'm going to make $25 per item, so profit really is 25x. And how many items do I need to make to break even? Well, to break even in this scenario, I have to have my setup costs equal my profit, right? So when my setup costs finally hit my profit, that's the break-even point. That's when I finally start going from a loss to a profit. Setup costs are $5,000, as we showed here. Profit is really 25 times the number of jewelry items. So if I take and rearrange the equation, I have x equals 5,000 divided by 25. So my break even is whenever I've made that 200th, or actually whenever I've sold my 200th piece of jewelry. That's the break even. Now let me show you what that looks like visually. Let's take, again, convert all of this stuff into lines. If this is my income over here on my y-axis, and the x-axis is the number of items that I make, you can see that as I increase the number of items that I make, my income will go up. So whenever I make one item, when x equals 1, my income will be $25. However, I haven't made a profit yet, right? Because if I draw another line in here at $5,000, this is my amount of money that I have already invested. So if this is the amount of money that I put into setup cost, $5,000, this is my equation for profit equals $25 times every item that I make. If I draw this in here graphically, you can see that at the point that these intersect, that's my break-even point. You see I'm going from a loss here to a profit up here. So if I can go back in and I can set this thing up graphically, this X right here should be exactly where this line and this line intersect. That's the basics behind linear programming. What we're really trying to do is take all of our information, turn it into equations so I can put it onto a graph, visually see it, and also be able to solve it using math like we did back over here that you could do in Excel. That's the introduction. Good luck. Let me know if you have any questions.